Walsh Newscast.
Okay, just a quick review of some stuff you need to know for this unit, because today's notes are like 7 minutes long, and I can probably still teach it in 2 minutes, so I've got 5 minutes to review. So here we go. I need you guys to be able to know your notations for things like this. If I were to give you f plus g of x, what does that mean? Add two functions together. This means add two functions together, right? This one means subtract two functions from each other. This one means divide two functions from each other. And when I mean divide their functions, I mean divide their y values from each other. Now, if I give you f closed dot g of x, that means multiply. But if I give you f open dot g of x, this is where you put
G of
x. Yeah, it means this. Okay, so there's one set of stuff you should know. Okay, if you know that, you just need to be able to apply it to whatever problem we're solving. Second thing you need to be able to do, you need to be able to factor pretty much anything. Okay, now there are some rules. You only have to go to the power of 5. I've rarely seen cubics, but you should be able to factor a cubic or a quartic fairly easily using things like the remainder theorem, factor theorem, just general knowledge of how to factor. General idea. Let's say that you get some sort of annoying polynomial, which is blah, 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 plus 7. Actually, that's a bad choice. Yeah, that was a poor choice. Because you get where I'm going here. Let's say if it's plus 4. Okay. You don't have to test a lot of things. You should try f of 1, f of -1, f of 2, f of -2, and so on, right? Let's say that f of 1 gives you 0. What does that mean?
X minus 1.
X minus 1 is a factor, which is why there's no remainder. Okay. So hopefully those are some skills you recall. So topic number 1, do you know how to combine your functions together? Add, subtract, multiply, divide, plus compose them by putting them inside each other. Topic 2, can you basically factor anything? Okay. And with the factoring anything, a really common question type is where they tell you like there's a factor of x minus 1, there's a factor of x plus 2. They tell you that there's a 0.17. Can you like tell me the rest of the equation by plugging 1 in for x and 7 in for y? Because like that came up on your test like every question. Okay, so those are new. Third thing that's new, pretty all-encompassing concept. Do you understand transformations? So if I were to give you f of x plus 3, what happened to the graph? If I were to give you f of 2x, what happened to the graph? Flips. No. Gets compressed in like this.
That's totally what it is.
If I give you negative f of x, what does it do? Flips. Head over heels, yeah. Okay. Now today I'm going to show you one more transformation. And so really, I've given you a huge list of them so far. This is one more. And here's how it looks. It's actually f of y. Huh? Which seems strange because what this right here means is replace all of your x's with 2x. This means replace all of your x's with x plus 3. Well, what this means to do here is replace all of your x's with y's. Essentially what you're going to do is you're going to take your x and y coordinates and flip them around. And this is honestly the easiest thing in the world. That's why there's only 4 slides. Okay. We're going to talk about what's called an inverse function, and this is the notation you may see. X equals f of y. Well, f bracket y means everywhere you used to have an x, put a y. Or everywhere you used to have a y.
Emma Allen.
This is the other notation you might see. You might see it as f minus 1x. But I have to point one thing out here. This -1 was poorly chosen because this is not the same as f of x to the -1. Do you guys remember what a to the power of -1 really means?
1 over.
Yeah, it means it's 1 over f of x. And that's a reciprocal function, which we're going to do in our non-polynomial section. So this is poorly chosen to put the -1 in between the f and the x. But if you ever see either of these notations, all you do is flip x and y around. Now, I found that this little thing sometimes helps kids to see how this looks. I'm just going to sketch a quick graph on paper here. Okay. Imagine this is my xy coordinates. and I were to draw some sort of function that looks like this. If you were to take what's called the inverse and flip x and y around, I'm going to do this properly. It looks like that. See how the smiley face used to be in this quadrant right here? Used to be right there. Now if you can see through the paper, see how through the paper it's down in this quadrant here? In this quadrant here, you used to have negative x, positive y. Everybody agree? In this quadrant here, you have negative x's, positive y's. Well, if you take a reciprocal, you now have negative y's, positive x's. And sometimes kids, they find it easiest to think of it as though you flip it over a diagonal. You can imagine having a diagonal and flipping it over a diagonal, that's kind of how it looks. I want to use the picture I had right here again. You guys can imagine this. Here's my diagonal. If I flip it over the diagonal, that's where it moves to. It used to be like this. Now it can move like that. You can almost imagine that it's like completely sideways, and then you flip it, that's how it looks. How's that? Let me show you some more pictures. See how this point right here used to be at, say, 4 and 1? All that we're doing is moving it over here, right there, to 1 and 4. Just take the two coordinates, flip the order. Think of it as, I know how I give really dumb analogies. So you know how I use like the vending machine analogy? Of like you give an input and it gives you an output. Okay, this is Boxing Day. And grandma just gave you a really, really bad sweater. You're now taking your output, the sweater, you're taking it back to the store and exchanging it for the input, which was money. You know what I'm saying here? So rather than money getting you sweater, X and Y, now Y is going back and giving you X. You're just reversing the process. So where are the invariant points? Right along this like diagonal line. Because take a look at this point here. It's 2, 2. Flip the two coordinates around. Flip 2 with 2. Same thing. Take this one right here. Negative 2 and negative 2. Flip them around. But take this point right here at 1 with 0. Where does it move to? Right there. 0 with 1. All you're doing is just choosing a look.
What's an invariant point?
So invariant points would have to be along this line of y equals x. That diagonal line of y equals x, I mean, by definition, is where y is x. Right? And so if I ask you to flip the order of x and y around, but they're the same as each other, then you would never notice. The point 7, 7 would move. What would happen if you had 7, 8? What would it turn into?
8, 7.
8, 7. Okay, now it moves, right? But if you had the point A, A, it would stay A, right? Like if this was a 2 and that was a 2, then I know you're changing the order, but you never tell the difference. All right, 2 quick tasks. I think I blew through 7 minutes of that. Ah, 8. Okay. Okay, so let's just sketch what just random points would look like if I asked you to find f negative 1x, which really just means all your y's are x's. So if it was at negative 5 and negative 2, now we need negative 2, negative 5. If it was negative 1 and 3, now you need 3 and negative 1. If it was 3 and 2, now you need 2 and 3. And if it was 6 and negative 4, you need negative 4 and 6. All you do, flip them around. This is actually one of the easiest things we do. So this is your last type of transformation. Things you can transform. Second, finish right, I'll wash my hands. You can translate by literally taking the entire graph and sliding it side to side, or up and down. That involves adding or subtracting a number, either inside or outside of the brackets, depending on which one you have. You can squish, pull out, squish, or pull out. That means multiplying by, like, say, 2 would do this, or 1/2 would do this. If it was 2x, it squishes it in. If it's 1/2 x, it pulls it. Okay. You can also flip this way, or flip this way. This is our last transformation. Rather than flipping like this, or flipping like this, you're flipping like this. You know what I'm saying? Like you're flipping diagonally. That's the last one. So I need you guys to be able to deal with this with points. If I gave you a picture of a graph, you should be able to sketch where it shows up at. The last thing you should be able to do is work with an equation. So I'm done. If I were to give you an equation, could you find this thing's inverse? It's not as hard as you think. What does an inverse mean to do? No, that's reciprocal. An inverse means to find f of y. So what does f of y mean? Take all of your x's and make them y's. An inverse, which we write f minus 1x, literally means to take all of your x's and make them y's. Okay, well this is now a y. Now, this over here used to be y though, right? Well, if x becomes y, y has to become x. So really, here's a better way of writing it. X equals 3y minus 2 squared minus 1. Literally, all I've done is I'm just changing my x and y's order. Now, is this a typical way of writing an equation though? We usually write it with y equals, so all we have to do is just undo a bunch of calculations to get y by itself. So for example, add 1 to both sides. Divide everything by 3. Get rid of the squared side. Square root. Take the positive and negative square root, by the way. And then when you're done that, add 2. There. That would be our inverse. Okay, that's our unit. So quick summary. Really, I can break it into 3 pieces. Piece of what? Do you understand the terminology? I give you f of f plus g. It means add. Right, f minus g. All that sort of stuff. So really there's 5. You need to be able to do add, subtract, multiply, divide, and put a function inside another function. If you can handle those 5, and however I ask you a question, that's topic 1. Topic 2, can you factor basically anything? If you can factor, you're good to go. Don't forget to use quadratic formulas, basic factor methods, common sense. But really the best thing to do is just take that constant term and guess and check factors of the constant term. Right? As part of that, you should know how to do either long division or synthetic division. And then the last thing is you know how to transform functions and move them around. Okay, I think there's just one last diploma question on here, right? Okay. So this used to be on a diploma, try it. Here's like a partial random snippet of a function. I'm now asking you to do x equals f of y. Which one's it going to be? So, I mean, what some kids might do is they might draw on this diagonal line, and then they'd say, okay, well, everything that was on this line would move. This little piece would move over to there, and then this little piece would flip over to here. So it would be A, I guess. All right, done. 13 minutes. That was